If Red Rock feels strange at first, that's because it is a business simulation, not just a quiz. You get an objective, exhibits, draggable information, a journal, analysis questions, a report, a chart task, and many cases. The skill here is knowing what to select. You need to know what belongs to the journal, what to ignore, which formula to use, and how to turn the numbers into a clear recommendation. In this walkthrough, the goal is not to just understand the answer. The goal is to understand how the case is built so the screen feels less random while you work. All right, for the sake of this walkthrough, we're going to use Stratosat Satellite Launch Planning case on Cognidoor's Red Rock case library. All right, let's open the case. You'll notice that once we open the case, we've got two options. The first is coach mode, and the second is exam replica. Exam replica aims to simulate the actual Red Rock assessment that you'll be taking during the solve assessment, while coach mode is Cognidoor's step-by-step coach that helps you understand the kind of selections you need to make, as well as how you should be thinking as you go through the assessment. All right, let's start. Before we start, it's important for us to familiarize ourselves with the platform. You'll notice that on the left side is the navigation panel, which shows you where in the assessment you're at. And on the right side, you have the most important part, the journal, which is where you capture key information pertaining to the case. And then you also have the calculator, which is very important because this is how the game assesses your ability to calculate quick math. And then you also have the coach at the bottom. This is Cognidoor's coach, which has a quick read section, which shows you very glanceable information and tries to direct you in the right path. And for more detailed information, you have the coach breakdown, which tells you what to do, the kind of selections you should make, what's missing, why it matters, and a note that tells you which direction you should be thinking. All right, let's start. So once we start the simulation, it's very important that you take at least 10 seconds to read the directions, because this notifies McKinsey that at least you're taking time to think about what's required of you. Once we're done with that, we move on to the objective. The objective is very important because this tells us the exact problem we're trying to solve. So we're going to drag this into our journal, but we'll return to it in a moment. Right, now that we move on to the study section, let's understand exactly what this case is about. Stratosat is a connectivity program for underserved regions in Africa, Asia, and South America. The case gives 4 satellite technologies that they're considering: SBA, ABS, LoRa, and MeshX. And our job is to choose 2 technologies for the first wave rollout, and the selected pair must have the following criteria. First, it must stay within the $42 million program cap. Second, it must reach at least a 7.80 combined weighted regional value score. And third, it should keep expected launch timing at 12 months or less. So the case is not asking which single technology looks best. It's asking which pairs are feasible, which pair has the best score, and can we explain the recommendation clearly. That is the whole decision frame. Back to step 1. The study is where we build our working file. Here we see draggable facts that we need. We also see more than we actually need, and that's intentional. Do not drag something just because it's available. Drag it if it helps you calculate, filter, or explain the final answer. The question to ask is, will this help me later in the analysis, report, chart, or many cases? If yes, collect it. If not, leave it. So, for what we're going to drag, we've already dragged the primary objective, which states that we need to choose 2 technologies for the first wave rollout, which combined have a $42 million program cap. And this matters because the case is about the best pair, not about the best single technology. Second, we drag the regional weights, which show that Africa is 40%, Asia is 35%, and South America is 25%. These matter because they tell us how to turn regional scores into one weighted value. After that, we have the program cap of $42 million. And this matters because any pair above that cap is out, even if it scores well. Following that, we have the contingency rule, which is 8% of combined R&D. We drag that over because it changes every spend calculation. After that, we have the weighted regional value threshold of 7.80. And we need that because every pair must clear this score to be feasible. So we drag it over. And finally, we have the expected launch timing threshold of 12 months or less. And this matters because the timing is a pass or fail constraint. So once we drag it, that's it. That's enough for this study section. We do not need to copy the whole page. And that's the key information we need. And if you look at the coach, it tells us that we've actually dragged some of the right selections for this section. All right, let's move on to Exhibit A. Exhibit A is a technology profile. And here we need to drag cost and timing inputs first. So it's very important for us to understand what the cost inputs are and what the timing inputs are. First, let's drag the cost inputs. For SBA, we drag the R&D of 16 and the support of 2.5. For ABS, we drag the R&D of 20 and the support of 3. For Lorraine, we drag the R&D of 13 and the support of 2. And for MeshX, we drag the R&D of 18 and the support of 3.2. These matter because they tell us to test whether each two technology pairs stay within the 42 million cost cap. For example, SBA and Lorraine uses 16 plus 13 for R&D and 2.5 plus 2.0 for support. Now, for timing, it gets a little bit more complicated. Here, for SBA, we drag the base of 9 because that's our base launch time. And then we drag the delay probability of 0.18 because that shows us our probability of not reaching our expected completion time. And then we drag the delay impact of 3 because that shows us how many months would be impacted if we delay. For ABS, we drag the base of 8, the delay probability of 0.12, and the delay impact of 2. For Lorraine, we drag the base of 6, the delay probability of 0.2, and the delay impact of 4. For MeshX, we drag the base of 7, the delay probability of 0.1, and the delay impact of 1. And the formula here is the expected launch time is equals to the base time plus the probability multiplied by the delay impact. These matter because they tell us whether the selected technologies stay within the 12-month launching timing threshold. For SBA, for example, it would be 9 plus 0.18 multiplied by 3, which gives us a total of 9.54 months, which is well below the 12-month threshold. All right, now you'll also notice other metrics like strategic rating and agility. While these matter, they're not very useful for us because they are not final decision filters. The final pair is decided by budget, weighted regional value, and timing. All right, now that we're done with this, let's move on to Exhibit B. In Exhibit B, we drag the regional scores for all 4 technologies, and they're worth collecting because the final decision compares pairs. This matters because these numbers show how each technology performs in the region Stratosat cares about the most. So we're just going to go ahead and drag every number here. For Africa first, for Asia second, and South America third. Great. Now that we've done that, we move on to Exhibit C. Now, Exhibit C is a 3-year coverage map. Here, we're reading a time trend, not necessarily doing anything that helps us choose the final pair. For the journal, the key takeaway here is it covers changes over time by technology. This exhibit matters because it helps us with any future chart task that's to come, not for the final pair decision. Because the data moves across years, it points towards a line chart. But because this is not part of the final decision, we will not use it to put it in our journal. So that's the kind of discretion we need as we go through Red Rock. So we're going to skip this one. And then finally, we come to Exhibit D, which shows us the program cap waterfall components. Here, it's best for us to drag the budget formula, where total spend is equals to combined R&D plus combined launch support plus 8% of combined R&D. That is the most important one that we need. So we're going to drag that one over there. And we'll also drag the combined launch support. What these help us with is to understand the kind of formulas we need as we do our calculations in the analysis section. And they matter because the final recommendation, again, has to pass the budget cap. And for any pair, we add the 2 R&D costs and we add the 2 support costs and calculate 8% of the R&D total. And then we add all the 3 pieces. So without these formulas, we wouldn't be able to understand that. Now that we've put that into our journal, let's recap step 1. So by the end of the study, our journal should have these exact dragged items or notes: the objective, cap constraints, regional weights, our budget rule, the R&D and support costs, the timing inputs, the regional scores, and finally, our coverage takeaway. We do not need to collect every sentence. The full strategic rating table, the full agility table, or the full coverage table are not important for the final decision. A good journal is not the longest journal. It is a journal that gives you the numbers you will actually use. All right, let's move on to step 2, the analysis. Before calculating, we first need to understand the math type. In this case, for example, we have simple lookups, weighted averages, arithmetic, expected value, and percentage point comparison, and comparing 2 different metrics under certain constraints. Once we understand that, we're able to figure out the kind of math that we need to go through each question. So let's start with question 1, which asks us which technology has the highest strategic rating. And this comes from Exhibit A. And from Exhibit A, we know that all we have to do is simply look. No formula is needed here. The question asks for the highest single value in one column. So all we need to do is look at our journal and scan for the strategic rating column and pick the maximum. And from that, looking at our journal, we know that the maximum comes from Lorraine with 8.9. So all we do is we put Lorraine into the answer section, and that's it. We move on to question 2. Question 2 is a bit more complicated because it asks us, what is the weighted regional value score for ABS? This is a weighted average. We use a weighted average because Stratasat does not value each region equally. Africa matters the most at 40%, and Asia is next at 35%, and South America follows at 25%. So the score has to reflect those priorities. So, for example, we open our calculator. For Africa, that would be 8.6 multiplied by 0.4, which would give us 3.44. For Asia, it would be 8.4 multiplied by 35%, which would give us 2.94. And then for South America, it would be 7.5 multiplied by 25%, which would give us 1.875. And we add all those together, and the final answer we get is 8.255. And we round this answer up, and the answer would be 8.26. That's it. But we need to watch out because we need to use the regional weights. So when you take this case, do not average the 3 regions equally. All right, let's move on to question 3. Question 3 says, what is the total program spend for SBA and Lorraine, including support and contingency? This is budget arithmetic. So we use the program spend formula because the case has a hard $42 million cap. The pair is only feasible if the full spend includes R&D, launch support, and the contingency buffer. So, for this one, once again, we use our calculator. The combined R&D is 16 plus 13. And 16 plus 13 is 29. By the way, what you're also able to do here is drag any of those numbers into the answer bar or into the journal. For this sake, we're going to combine R&D plus combined support plus contingency, and then the total spend would be 29 plus 4.5 plus 2.32, which will give us an answer of 35.82 million. Right, so that's all it is, 35.82. And that is the answer here. But once again, we need to watch out because the 8% contingency rule matters only on R&D. All right, let's move on to question 4. Here, we're looking at the expected launch time. So the question is, what is the expected launch time for SBA? This is expected value. We use expected value because launch timing includes risk. The base time tells you the normal timeline, and probability multiplied by impact adds the average delay that we should expect from the risk. So our base time is 9 months. So we're going to say 9, and our expected delay would be 0.18 multiplied by 3. So we're going to say 9 plus, in brackets, 0.18 multiplied by 3, close brackets. Then we're going to add that. Then the number we get is 9.54, and that's our answer. So we just drag it over there, and we're done. Then we move on to question 5, which is once again a little bit more complicated. This asks us the best pair under all the constraints. So this is the core decision question that our objective is trying to answer. Here, we can use a filter and then optimize our approach. So we first remove the pairs that break the cap or score threshold. And only after that do we choose the highest scoring feasible pair. So for example, from our journal, we know that SBA has a weighted regional score of 7.33, ABS of 8.26, Lorray of 7.68, and MeshX of 8.12. Then we test the pairs. For this score, we average the two technologies' weighted scores because the case asks for the combined scores of two technology pairs. So we start with SBA and ABS, which once done has a cap of 44.38 million, which is way over our cap. Then we go to SBA and Lorray, which has a final of 35.82 million, as we calculated before, which is below the threshold. And then SBA and MeshX, then ABS and Lorray, and ABS and MeshX, and Lorray and MeshX. And from this, we will understand what's feasible. The feasible pairs from calculations are ABS and Lorray and MeshX. But between those, we only choose ABS and Lorray because they have the highest score while continuing to be below our threshold. So that's all we need to do. And the case here gives you a good example of how we can calculate the formula. All right, so the answer would be ABS and Lorray. And once we're done with question 5, we move on to question 6. This one is rather simple. By how many percentage points is MeshX's agility benefit higher than Lorray's? So all we do here is do some simple subtraction. We know from the earlier chart that MeshX's agility was 34%. And we know that Lorray was 24%. So we subtract the two from each other and we get the answer of 10. And all we have to do is drag that into the field and we complete. Once we're done with that, we get to review our answers before we move on from this stage. I'm pretty confident in our selections, so we're going to seal the stage, and then we move on to the recommendation section. But before we do that, let's recap step 2. The highest strategic rating went to Lorray, and ABS scored the highest regional score. SBA and Lorray had a total spend of $35.82 million, which was below our $42 million cap. So looking at the recommendation summary, our selected choices were ABS and Lorray. And the total program spend for ABS and Lorray was $40.64 million. So you put 40.64 right there. And the weighted regional score for both was 7.97. So we put that there. And the expected launch time for them was 9 months. So that was definitely below the 12-month launch time. And the best year 3 coverage region logic came from SBA. So all we do there is put in SBA. And that's our whole recommendation. If we were to read it like we're talking to an executive in a case, what we would say is the best technologies would be ABS and Lorray because they come below the $42 million budget cap at 40.64. They also have the best combined weighted regional score of 7.97, and the expected launch time would be 9 months. And that's it. And then we move on to the graph selection. So the graph selection is fairly simple. We're asked, which chart is best for showing how added coverage evolves over 3 years for 4 technologies? Right. So what we know is that the best way to figure out evolution over time would be using a line chart. So all we do is we select the line chart. So here we choose line, and that's it. Great. Once we get to the visual report, we think very carefully about how we design charts. We know that in the x-axis, we should put the year. And we know that in the y-axis, we'd rather put the coverage map, which shows us the number of people. And then our series would look at technology because we're trying to understand the number of people who'd be covered by the technology. Then the chart that we would use is a line chart. This map works because year goes on the x-axis because it is a time dimension, and added coverage goes on the y-axis because it measures value, while technology is a series because each technology needs its own line. That setup makes the chart answer the actual question, how coverage changes over time for each technology. All right, now we get to the mini cases. So we'll begin with mini case 2. If South America weight rises from 25 to 35% and Asia falls to 25%, which technology gains most? So all we do here is use directional logic before calculating. If South America becomes more important, the technology with the strongest South America score benefits first. Then South America becomes more important. And Lorray has the strongest South America score at 9.2. So our answer here is Lorray. Great. Then we go to mini case 3. What is the expected delay for Lorray? This asks for the delay only, not the base time and the delay. So all we do here is we use probability multiplied by impact because the question asks only for the expected delay. We do not add the base launch time here. So all we do is the probability of 0.2 and the delay impact of 4 months, which we multiply together. 0.2 multiplied by 4 will give us 0.8 months. And that is our answer, 0.80. Right. Question 4 asks, if MeshX support cost increases by $1 million, does Lorray and MeshX still stay under the original $42 million cap? So here we use an incremental adjustment because only one input changed. So we start from the old Lorray and MeshX spend and then add the extra support cost. So this would be the R&D of 13 plus 18, the support of 2 plus 3.2, and the contingency, which would be 8% of R&D, which would be 2.48%. So all we do is we add the 2.48 to 5.2 to 31, which gives us a total of 38.68 million. Now, we also add the 1 million support increase, which takes us to 39.68 million. So the answer is yes. 38.68 million is still below the $42 million cap. So all we do here is put in the answer yes. And then we get to the review section, which shows us everything that we've done. And once we've done that, we just seal, and then we complete our Red Rock case. So now that we're done with the case, here's how to think about Red Rock. A strong Stratosat run is selective. We collect the objective. We keep the journal useful, not huge. We match each question to the right math type. We apply contingency to combined R&D. We filter by constraints. We carry the exact analysis, and we reuse the same logic in many cases. The recommendation is clear and very clean. Now, that is what Red Rock is training. Selective evidence, clean math, and a recommendation you can defend. Don't forget to use Cognidoor's Coach, which can help you understand what you should think, what you should reuse, as well as the type of stuff you should be putting in your journal. Once you're done with the case, you can get very valuable feedback that can help you improve on your next case and help you think about the strategic choices you should be making so that you can pass Red Rock. If you're interested in more content relating to consulting assessment cases, stick around because we'll be making more videos that can help you ace the assessments. See you in the next one.